Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 35, Adding Physics to Sprites. In the previous video, we finished writing the code for the new physics class, which we're going to use to make our sprites have more realistic movement. In particular, they will gradually speed up and gradually slow down. So, in this code, we're going to now integrate that physics class into our library. So first, let's go ahead and open up that development environment. So here we are with IntelliJ, and let's open up the Sprite class. Right, so in the Sprite class, let's go all the way up to the top. We have a lot of information in here. Sprites extend entities, I hope you remember. And let's see, sprites have positions, they have angles, they could be mirrored or flipped, they have opacity, they're displayed with textures, they have a collision boundary, they have a width and a height, and they may or may not be visible. So next we're going to add some physics. So let's say public physics. P-H-Y-S-I-C-S. All right. Now, one of the interesting things about physics is it might not be the case that all objects need physics-based movement. Right? They might stay in the same location. So, for example, those rocks in our game, they probably aren't going to move around. The ocean as well is going to stay still. Right? So, physics, by default, and let's just say that's equal to null, and then we have the option of setting a physics object later on. Right, we'll just create a set physics method down here. We can set all sorts of things. So let's go ahead and say public void set physics. Right, this will take in a physics object P, and I'll say the physics object is equal to whatever this is. Maybe I'll call it Phys. All right. Now, again, not everything is going to have a physics object. What we'd like to say next is, if there is a physics object, then update the position using the update function in physics. And as we see here, right, there's not really a place where we can automatically execute code. Right, there is the draw method, which gets called automatically. Right, you might recall in our game class, let's go ahead and open that one up. Right, in our game class, we have our main group. That's defined right at the top of the class there. Right, so this is the root collection of all the different sprites and groups of sprites we need in our game. And then during the main loop, which we call the game loop, and that's an animation timer, and right, that will run the update method. However, if we think about design principles, we might also want to update individual sprites or entities within our game. And this leads us toward thinking we might want to write an update method for individual sprites as well. So we're going to go ahead and add that to our entity framework. It's really not too bad. We've got first the abstract class entity. Right, we're going to add a new abstract method that must be implemented called update. And we'll also take in something called dt, which again will stand for delta time and tell us how much time has elapsed. And so each entity should be able to update its own internal data if necessary. And so right now, let's see, we've got an abstract method called update. Oh, and we also need a void. Right, this isn't going to return a value, it's just going to update sprites. The way we'll update a group will be the same way we draw a group. And remember, the group is a class which contains usually a list of sprites or a list of entities. So similar to our draw method, right, we'll write a method. In fact, I'll copy this code. Right, this is going to implement not the draw, but this will implement update. So it must take in a parameter, a double dt. And what we'll do for every entity in the list corresponding to this group, we will update that entity, telling it again how much time has passed, what delta time is. Right? And let's even put a comment in here. And so we want to update all entity objects in this collection. For now, that's just going to mean updating the physics data if it exists. Later on, as we add things like animation and an action system, we're going to get a lot of use out of this update method. Okay, so we've written update for entity, we've written it for group. Next, let's write it for sprite class. Right, so let's implement this. This will be, where do I want to put this? Maybe I'll actually put it before the draw method. Let's say public void update, take in a double DT. And this is where, if physics has been defined, we'll use that to update the position. Right, so let's say if physics is not null, right? If some physics data has been set. Well, then we'll want to copy over our current position into the physics object. Right, so let's say physics.position, right, let's say set values. We'll just copy over what's in this object's position. So I'll say this.position.x and this.position.y. And so we'll do that first. Next, we'll say, hey, physics, go ahead and update your internal position data. So physics.update, as always, it needs to know what dt is, and so it knows how much of the acceleration and velocity should be applied. And then, once physics is updated, physics internally stores that new position data, and we'll need to copy it into the position data for this sprite. So this.position.setValues. And this is going to look like physics.position.x and physics.position.y. Let's bring that back up here. And there we go. So if physics data has been set, then we'll go ahead and use that data. All right. That's all we need for this class, I think. Right. The last thing we'll want to do, right, this is something we need to not forget about, is the game class. Right? Every entity can now be updated, just like every entity can be drawn. We need to tell the game class to also run that function as well. So not only are we doing a self-update, but let's also do self.group.update. Right? Update, it could be confusing to have two instances of the update method here. This update, the update belonging to a game, it kind of takes care of all the interaction between different game objects. Whereas this update is going to have every element in this group, every element in this collection, update its own internal data. And here it needs a parameter. This is supposed to be the amount of time that is elapsed. We could calculate this more correctly, but for our simple games for now, we know this is going to be a 60th of a second. So I'll say it's 1 divided by 60. I'm adding in the decimal here, so I don't get an int value, so this isn't accidentally sent to 0. All right, that's it for adding it to the library. Let's add it to the game. So let's head over to the sprite class. Actually, let's close the sprite class. Let's close all of these classes. Let's go to Starfish Collector. And just so we can see and appreciate the changes we're about to make, just as a trip down memory lane, let's go ahead and run the Starfish Collector game. And let's remind ourselves what movement looks like. And so right now, we've got our turtle. Right now, if I push an arrow key, right, it immediately starts going at a certain speed. If I let go, it immediately stops. Right? That turtle can stop on a dime. So let's go ahead and let's add physics functionality. Right? Notice nothing has really changed because no objects have physics set. So let's go down to where we declare the turtle. Right? In addition to setting a texture, we're going to do another thing here. We're also going to set a physics object for the turtle. And so let's say turtle.setPhysics. Right? And this is going to be a new physics object. And there's 3 values we need to put in here. First, how quickly can it accelerate? What's the maximum speed it can take? And what's the deceleration? Once we let go, how quickly does it slow down? So let's think about this, and maybe out of order. The maximum speed, maybe 200 pixels per second. Right, so it's going to be some number, 200 pixels per second, and then some deceleration. So acceleration, how quickly do we want it to get to its maximum speed? Right, so we could try out values and then adjust them later depending on the feel of the game. Right, if I say something like 100, that means every second that I hold down an arrow key, it'll pick up a speed of 100 pixels per second. It'll take a total of 2 seconds in that case to reach its maximum speed of 200. And let's try setting the deceleration to the same value as well. Right, so that'll be the physics, the speed, and the acceleration, deceleration for this turtle. Does this fit on one line nicely? It does. So we'll leave it on one line for now. All right, we've set the physics. Now we actually need to use it in the update method. In the update method, as it stands, we've just been setting these values directly. Right, so we've been changing the position by 2 pixels per frame. What we'd like to do now is instead we're going to use that accelerate at angle. Going to the right, that's an angle of 0 degrees. Right, let's say going to the left, we're going to accelerate at an angle of 180. That angle goes towards the left. Oh, and you know what? I can't call these directly on the turtle. That's why that's in red. These methods belong to the physics object of the turtle. Right? We're delegating all that action to physics. So turtle physics, accelerate at angle. If we're accelerating up, that's going to be an angle of 270 degrees. So accelerate at angle 270. And then pressing down, we could say accelerate at turtle.physics. Accelerate at angle 90. All right. And that should be our physics. So let's go ahead and give this a try. So we'll run Starfish Collector. All right. So now, if I push the arrow key, well, if I hit something, I'm going to slow down pretty fast. Notice, I pick my finger up off the arrow key and then it slows down. And it takes about 2 seconds to slow down and 2 seconds to get up to speed. Right, now, that could be a problem if you're trying to navigate near this shark, right, and you let go. Right, it might be a little bit too slow. The way we have the game set up right now, the shark is just a friendly observer and it doesn't end your game. But you could imagine a version where you're trying to avoid this shark. In fact, if I'm trying to move the turtle around, the turtle feels slippery for lack of a better explanation. Right? The turtle is slow to adjust its position, or slow to adjust its direction of movement. And that might be the feeling you're going for. If you'd like to have slightly more responsive movements, what we could do is just change the physics settings. Right, so in this case, right, with these small acceleration and deceleration values, it takes 2 seconds. What if I set these to 400? What does that mean? It might sound like we're going really fast, but really it just means we achieve this maximum speed very fast. In this case, if we can accelerate at 400 pixels per second, that means it'll take half a second to get up to our maximum speed. So with those number changes, let's go ahead and try running the game one more time. Let's see how this looks. All right. So now I get to speed a little bit faster, and when I let go of the arrow key, we slow down a little bit faster. It seems like a reasonable speed, good controls. The turtle still does slide around a little bit, but that's okay. If you really didn't want the turtle to slide around at all, you could set the acceleration, deceleration even higher. But this feels a little bit better. Okay, the other thing I'd like to do is take advantage of another physics method. You might notice some of this code feels a little bit redundant, all these set angles. What I'd like to do is set the angle that the turtle is facing to be the angle at which it's moving. Right? These are two different quantities. You might be facing in one angle and moving in another. Right? I can face in this direction and I can still move to the side. But here, what I'd like to do is I'm going to get rid of a lot of this code here. Right? The code's going to get shorter and more efficient, which is always a good thing. And let's get rid of some of these. Since we're only going to really execute one statement in each case, don't really need the braces. All right. So what I'd like to do is set the angle of the turtle to be the turtle's angle of motion. And you know that your methods are well named when they translate into the language you're using to describe your application. So turtle, I'd like you to set your angle. In particular, this is the angle at which the turtle's moving. Oh no, this is the angle at which the turtle's facing. We'd like this to be, get that from turtle physics, get motion angle. All right. And hopefully we won't see much of a change in our application. There is still one more thing we'll need to do, but this is about it. All right, running that game. Once again, added bonus. Right, in this case, we no longer have discrete angles. Right, because if you push left and then right and up and down, right, your angle of motion can be the combination of two forces in different directions. So, nice bonus. However, there is a problem still. Right? And I won the game too quickly to actually let you see the problem. Let's run this again. You might have noticed once when I was playing the game, if I go down and then I let go, notice that the turtle snaps back to looking to the right. And the reason that happens is the turtle's facing the correct direction as long as the turtle's still moving. Once the turtle stops moving, what value does get motion angle return? Right? As we've mentioned before, get motion angle is kind of meaningless if you're not moving anywhere. If your speed is 0, then the motion angle is by default going to return 0. Right? So it'll always snap you back to that position. So what we should do is we should only change the angle of the turtle if the turtle is actually moving, if the speed is greater than 0. So we're going to add an if condition here. If the turtle physics get speed, if that's bigger than 0. In other words, if the turtle is moving, then we'll set the turtle's angle at which it's facing to be the angle at which it's moving. I should go ahead and indent that. Now let's give that a try. All right, so moving around at different angles, and then I let go. And now the turtle's not moving, the speed is 0, and that condition does not kick in. Right? The turtle remains facing in the angle it was going in. All right, so this is starting to become a much better looking game. All right, so that's going to be it for this part of the video. And the next set of videos, we're going to start talking about sprite sheet based animations. Right? Things are moving across the screen, but we can make them look even better. But right now, this is a good breaking point, so we'll stop this video. Thank you for watching.